Okay, so for this video, we're looking at ions, isotopes, and atomic number. So kind of the goal of this lesson is to be able to identify what makes an ion or an isotope and how to represent different atoms in their symbol format. So before we get into that, we just want to do a quick review of kind of the structure of the atom. So when we have our atom, there's two parts to it. We have the nucleus and not the nucleus. So in the nucleus, we have protons with positive charge and neutrons with no charge. So, something like this. We got a couple protons, we got a couple neutrons, that sort of thing. Outside the nucleus, that's where we have our electrons. I'm going to draw them in a Bohr model here. Maybe I'll draw one more. Okay. So this is what we're working with when we're talking about atoms, is we're trying to remember that, okay, we have protons and neutrons in the nucleus, and those are massive. Mass is meaning that they're large and they have mass compared to electrons. Electrons are tiny and they're flying around outside the nucleus. Okay, so let's first talk about atomic number. So atomic number is the number of protons in an atom. The atomic number is what determines an element on the periodic table. So for instance, this example here, carbon is element 6. It has 6 protons in it. An element with 3 protons will always be lithium, because lithium is element 3 on the periodic table, and so forth. And when we write the atomic number, that goes in the left of our symbol form writing. So if I'm writing carbon, I would put the 6 down there. That's its atomic number. Atomic number, also known as the number of protons. Okay, so remember, that's very important. The atomic number determines what element an atom is. So the more protons you have, that changes the element. Okay, so next we come to ions. So when we're talking about ions, we're talking about the charge of an atom. So here it says an atom is considered neutral if the number of protons and the number of electrons are equal. So if I have an atom and it has 3 protons, it has some neutrons, and then it has 1, 2, 3 electrons, this would be a neutral atom because the number of positives is equal to the number of negatives. So atoms are called ions if the proton and electron numbers are different. Okay, so let's say I have an atom with 3 protons and only 2 electrons. So important thing here is now I have 3 positive charge and 2 negative charge, which overall is going to result in a positive 1 charge on this ion here. Okay, so ions are atoms with a charge. Now, something to keep in mind when we're talking about ions is that the thing that's changing is typically electrons, right? We just said up here that the number of protons determines what element an atom is. And so if you change the number of protons, you're actually changing elements. So typically what we see change are the number of electrons. Also, it makes sense, electrons are outside the nucleus. They're much more accessible and easy to change. So when we're talking about ions, atoms with a charge, we're either adding or subtracting electrons from an atom. Now when we write the symbol form for an ion, we put the charge in the top right corner here. So in this example, this lead ion has a -2 charge. This potassium has a +1 charge. Kind of a side note, you can write +1 or you can just write plus. Scientists are lazy and like leaving that out. But that's where when we're writing the symbol notation, we would write the charge. Okay, so next we have isotopes. So isotopes are atoms of the same element with different mass numbers. Same element. So earlier we had talked about how neutrons and protons are massive. So when we're talking about mass number, The mass number is the number of protons plus the number of neutrons in an atom. Okay, so for this example up here, I have oxygen 16, so it has 8 protons, 8 neutrons. Oxygen 17 is an isotope with a different mass. It has 17 things, 17 massive things. In this case, 8 protons, 9 neutrons. And then oxygen 18 has 8 protons, 10 neutrons. Now you notice that the neutrons change. Again, this is because the number of protons determines the element. So if I have oxygen with different mass, it has to be oxygen each time, and oxygen is element 8 on the periodic table. So we'll always have 8 protons, and the number of neutrons is what changes to give each of these isotopes a different mass. Okay. Now we're talking about mass. The units that we use are AMU, atomic mass units, which is basically just saying that 1 proton or 1 neutron is equivalent to 1 atomic mass unit. So this number is always a whole number when we're talking about isotopes. So I could have carbon with a mass of 15, which would mean it would have 15 protons and neutrons in it. One thing to note, this is not the mass that's listed on the periodic table. That's the average atomic mass, which we'll talk about next time. But when we're writing out the symbol notation, so we've already mentioned that the bottom left corner is the atomic number, or the number of protons. The top right corner is the charge. So in this case, for this carbon, it doesn't have a charge. It's just neutral. So the top left corner here, this is for the atomic mass. So we can use the atomic mass and the atomic number to figure out how many neutrons are in an atom. So in this case, this carbon has a mass of 12. So and it's element 6, so it has 6 protons. So you can use that. I can say, okay, so the atomic mass is equal to the number of protons plus the number of neutrons. I know the atomic mass is 12 atomic mass units. The number of protons is 6. So I can figure out the number of neutrons and say that there are 6 neutrons in this atom to give it a total mass of 12. So that's kind of how we can use these numbers to help us out. Another side note here, when we're talking about the mass number, we can write this atom here, all atoms, but we can write them in hyphen notation, where we write the element followed by the mass after a dash. So in this case, this carbon 12 atom has a mass of 12. Okay, so here's a big practice. So we can look at this atom here. So this symbol, first thing I notice is that it's for chlorine, because it has the Cl there. I could write this in the hyphen notation. It has a mass of 37. So this is chlorine 37. Its atomic number is 17. So it has 17 protons. Okay, that's probably one of the easiest things to figure out. I already mentioned that the mass is 37, right? That's the top left corner. Now, when I try to figure out the number of electrons, I first have to look at the charge. Because remember, the charge, something that makes it an ion, is you change the number of electrons. So I say, okay, this has a charge of -1. It has an extra negative charge. And I remember that electrons are negative. So if it has an extra negative charge, it has an extra electron. And I say to myself, well, how many electrons did it have to start? Well, every atom in its base neutral form has equal numbers of protons and electrons. So this chlorine is element 17. It has 17 protons. And in its neutral state, we'll have 17 electrons. So if it now has a -1 charge, it has an extra electron, then it has 18 electrons. And then lastly, when I'm looking at the number of neutrons, I say, okay, well, I know the mass is 37 atomic mass units. I can subtract the number of protons, because mass is protons. Protons plus neutrons equals mass. So if the mass is 37, I can subtract the number of protons, and that leaves me 20 mass units left to be added, which means that there were 20 neutrons in this atom.